repeated. You always have to be able to repeat something. So there was, I know last time we talked about black holes, but there was this thing about cold fusion. Somebody thought they had fusion happen at a cool enough temperature to make it something. You guys know? And of course they tried to repeat it, they couldn't. So who knows what happened that first time around. So you always have to be able to repeat something, because there's a chance it could have happened just randomly. So, turned out the kid did not have ESP. Or he decided to hide it the second time around, I don't know. Dude. Medium? Yeah. Communing with spirits? Well, I guess if it's somewhere, then that's one definition. So, there's a few different theories about what causes ESP. So one of them, of course, could be talking with the spirits.
I just looked at it around because I've never...
I'm with you. All right, so maybe I'll look at those 5 types so I can talk about this thing. Because I don't know what the 5 types are, to be honest. Okay, so let's come back down from psychic and ESP and stuff. Everybody's got this here, right? The forward focus. Read that over. If you weren't here last time, this is going to suck a little bit, but you definitely want to email me if you weren't here last time, because there was a handout I gave, I think it was before last time, where it explains every step. The one that's got all the red writing on it explains every step of the hypothesis test. That sounds like it would be really useful. All right, so let's read through this thing. Blah, 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 blah. So it takes this long normally to assemble the forward focus. Modification is made, and now Ford believes it's changed. The assembly time has changed. Could have gotten better or worse. All right. They took a sample of 71 cars and find that it took this long to put them together with a standard deviation of this. That sounds exactly like the quiz did. This is a little early for this, but what kind of standard deviation is that? So what are the 2 types of standard deviation? There's either, it could be for the population or sample. Which one is that? Sample, because it came from the 71 cars. So I'm really sorry. I'm not going to, underline it and put S. I'm not going to. You've got to realize, you've got to take a second and consider, what is that standard deviation? Where did it come from? You have to determine for yourself. Okay. So I already know ahead of time we're going to use what scores? T-scores. I kind of know. So when we hit that step, we already know. What's the claim that's being made? Yeah, so the claim that's being made is, after this change on the assembly procedure, the mean time to put them together has not changed. Get out of it. The mean time is still, no, they say it's changed. Come on, Jen. The mean has changed from, so it's different from 38. So it used to be 38. They think it's changed. So they think the mean is no longer 38. So let me see if you guys understand this. How do I know when it's going to be a one-tailed test? When I see directional words. What the hell is a directional word? We think it's decreased, down. We think it's gone up, up. We think there's more, up. So that would mean I'm only interested in that side of the distribution. When I see something like, we think it's the same now, we think it's different now, we think it's changed, that there's no direction to that, it's 2 tails. Sorry, I just gave away this answer, so it's a 2-tailed test. Where does this statement go? Yeah, the high. Why? This is the most direct way to not have an equal sign if you have the exact opposite of an equal sign, right? So the ho's got to always have the equal sign, or the null hypothesis. You're easily offended. So what will that null be? Yeah, equal to the opposite of this dude. Right. So the null always has to have the equal sign. Which one is the claim is just whichever place it makes sense. If the claim does not have an equal sign, it's got to go for H1. If it did, it would go in for HO. Like it. We already talked about this. Now tell me really, really why we can use t-scores. What's the very first thing I should look for? If it's normal. And here I know it's normal because, yeah, n is 71, that's bigger than 30, check. So that means I can do something. And I know I keep saying this, but how do you know if it's T or Z is dependent on which standard deviation? Don't just say, I know the standard deviation, so that's Z. That doesn't make sense. Which standard deviation do you know? And in this case, where he said, sigma unknown, only S. So then we have to use t-scores. How are we doing? Say again? Yes, anyone is greater than 30. Yeah. That's good old central limit theorem. Saving our ass. Unsung hero. Yes? What is?
Oh, what is?
When do we use?
Nothing.
Nothing. All right. So what's, in order to use nothing, what is it that tells me I could do something? Which step told me I could do something? It's a normal distribution. So it's either got to say it's normal or the sample size has got to come in and save it. So if it didn't say it was normal and the sample size was less than 30, then we can't do anything officially. You guys with me? If you hit a problem like that, you think that's the case on a test or something, do the work anyway. Right? I will never give you a problem where you could save a lot of time if you just noticed you didn't have to do it. Does that make sense? I'm never going to do that. That would be so evil. Maybe when I'm about to retire, I'll just be like, screw everybody. Right, but I'm not there yet. Okay, all right. Now let me remind you of the basic idea behind a hypothesis test is I set up where evidence starts. So the whole idea is I always try to show evidence for this guy. I don't care what the claim is. The claim gets me started, and the claim is how I end it. In the middle, I'm always trying to show evidence for H1. Why? Because I can never show evidence for HO. It's got an equal sign. I can never show evidence that something equals something, but I can show evidence that it's not equal to in some way. Let me stop there for a second. So I'm always looking at the statement that thinks it's not equal to what the middle's supposed to be. Therefore, what do? I try to find a sample that is so far away from that middle that it's evidence. So what are the most important steps? How far away is far away enough? And then, how far away did we actually make it? Right? So I think about that step. That step we're about to do is like the benchmark. Here's a benchmark. Did you pass it or not? Sort of like if I always give an example, like if I had a football team and all my players are slow as hell. I want to draft a fast player. Right? I always think about Rocky this way. I want to draft somebody that can run really fast. So what I do is I set a certain time to run the entire football field twice. I'm like, if you could do it quicker than this time, that's the benchmark. That'll be evidence to me that I should let you on the team. You guys, how to get that idea? So this step C is setting that benchmark. Where's evidence start? And then step D is, did I make it far enough away? That really is all this is. So how do I set this up? What the shit? What did I tell you in the problem that helps me set this up? Say again? It's a two-tailed test. I'll have it, somebody write it down. So it's a two-tailed test. So I know which row to look at on the t-score chart. We are using t-scores, right? So I'm going to need a degrees of freedom. What's the degrees of freedom? Yeah, 70. So 71 minus 1 is 70. Sample size is 71. Degrees of freedom is always 1 less than that. I like it. We do that just because that's how they made the chart. They could have made the chart with n, but they really want to make you aware of the degrees of freedom. So I know it's two-tailed. I know the degrees of freedom is 70. What else do I need? I mean, can I find it now? What do I not know? I know to stop at 70. Level of significance, 11, which is related to a confidence interval, but this actually is kind of related to confidence interval because it is a two-tailed test, right? Confidence intervals are always two-tailed. So alpha here is 0.05. So that tells me which column to look at. So really, this is almost too nice to believe. I know it's 0.05, two tails, 0.05. So I go down to 70, bam. So that's how many standard deviations away I've got to get to show evidence, that or more, to show evidence that it's not what the middle they thought it was. It's different. Love you guys. Since it's two tails, I have already forgotten what I just looked at. What was it? 70. 1.994. So what do I put down here? Negative. Negative 1.994. That is almost what we used to consider unusual, right? Back before we were more sophisticated, we said 2 was always it. And now we're a little bit more nuanced. We're like, oh, depending on the situation, it might be 2. In this case, it's 1.994. That is where unusual starts. Any sample outside of there is unusual if 38 really is the middle. Therefore, that's evidence that 38 isn't really the middle. So you guys are like, you said that kind of thing before. I know. So how do I say this in words? Let me shade this in. There's my rejection regions. So the null, this dude in the coffee shop, thinks it's in here somewhere, close to 38. Assuming the middle is 38, this guy thinks it's around 38. But if I can find a sample that's way the shit out there somewhere, that's evidence that he's wrong. So if T star is how do I get in there? I have to be less than negative 1994, or T star is greater than positive 1994, then we can do what? Oh, is that out of that? Okay. We can do what? If I get out here, what can I do? What did I just say? Reject HO. That dude looks to be wrong. He's the one that thinks it's around here. He's the one that's got an equal sign in him. Always, because that's how we set it up. So if I find something out here, I can reject this dude. Support the other dude. So it looks like I just wrote two things. I didn't, because those are both the same situation. I think you're wrong, I think the other guy is right. I just said the same thing twice. Okay, like it, maybe. Now in this problem, I was unbelievably nice. Do not, I love my students who realize, I'm not going to put on this part, see how I put T star? So normally what I put down here is I'll say find Z star or T star. I don't want to give you a hint that, oh yeah, you're supposed to use T-scores, right? So don't get excited. Here I was nice. So what do we know from the sample? What's X bar? 37.3. And what is S? 2.25. So then I have to make SX bar, because this is the one for individuals. I need the one for groups of 71. So 2.25 divided by square root of 71 becomes 71. It was 0.29.
0.267.
0.267. Okay, I like it. And now what I want to do is I want to see how relatively far away did my sample get. What I do here is the number of standard deviations away. That formula never changes. I don't care if I call it TZ. The formula is always my data, 37.3, minus what I'm accepting the middle to be, 38, divided by the new spread. I think that's 2.7. Negative 2. I could be completely wrong. Fine with that. Maybe it's like something.
Negative 2.62.
Oh, that's not too bad. Negative 2.62, is that what you guys are getting? So did we make it far enough away? Where did that fall? Visually it fell right here. Shit. Way in there. Yeah, I like it. I like it. So I don't mean to do this to bore the shit out of you. I know sometimes I do that, but I say things over and over because it takes a while for it to sink in. This guy thinks it's in the middle. How do I show evidence it isn't? Well, just to be different isn't enough. Just to be different, any sample is going to be different. But the sample to show evidence has to be really different. So sure enough, we made it way the shit out here. That's really unlikely. So therefore, what can I say right now? Just a really quick little thing. What can I do? We did do this. So therefore, we can do these things. We succeeded, right? We made it. We found enough evidence. We exceeded the benchmark. Which was my claim? Which statement was my claim? The HO or the H1? H1 was the claim, therefore I want to use this language in my conclusion. There's no ambiguity about what to say. You talk about the claim. So whichever one the claim was, that's the word you use. And even beyond that, what makes sense? HO is the guy who thought I was in here. We got way the shit out here. So it looks like this guy is right. So that's what we're going to say. We have found evidence to support the claim. So we have found sufficient evidence to support. I love the fact that we do not say that we have proven. We can't. Found sufficient evidence to support the claim that what? The mean assembly time has changed from, what was it, 38 hours. And Ford hopefully would be more specific. They'd realize it actually got less, which is a good thing. That's evidence that it actually decreased. Okay. So you guys have probably started this already. Go ahead and try the one in the back. What about credit card debt? I remember my grad school years, I like to say they were very plastic. Took me a while to pay that off.